Now we are going to discuss about some satellites. They are asking problem for that type or also. What is satellite? When you launch a satellite you want to establish a satellite in one orbit, definitely it will start revolving the earth, from where it will get centripetal force to move in earth's in that orbit. It will get it from gravitational attraction between earth and satellite. Suppose mass of your satellite is m. It is your earth and you set this satellite at h distance from earth's surface. It means now it is revolving in an orbit of radius re plus h. So satellite needs one centripetal force which should be equal to, if its speed is v, it is orbital speed, so I am denoting by VO upon re plus h. It will get it from gravitational attraction, means g m, mass of earth, mass of satellite, upon re plus h whole square. Cancel m with m, means orbital speed of satellite is again independent of mass of satellite. So what it is coming? Gm upon re plus h. But what is the value of Gme? It is root g re square. So we are getting this. Now so many results are there, so many questions they can from this. If satellite is near the earth, it means if h is very smaller than radius of earth, you can ignore this h in addition. So what you will get, VO is equals to root GRE. G and RE are known. By putting these value, you will get nearly 7.92, or you can say 8 kilometer per second. It means the satellite which are orbiting near the earth's surface, their orbital speed is nearly 8 kilometer per second. They can ask you in competitive exam, if you want to escape the satellite from its orbit, by what percent you have to increase the speed of satellite? We know that near Earth's surface, orbital speed is root 2 GRE, but escape velocity is root 2 GRE. If you make this root 2 GRE, then only it will escape the orbit. So by what amount we have to increase this? If you want to make this. If you want this calculation in percentage, not a tough task. What is change in percentage? VE minus VO. Initially it was VO. We want to calculation for 100. So multiply this by 100. VE upon VO means root 2. VO upon VO means 1 into 100. So what we are getting? 1.414 minus 1 into 100. So we are getting 41.4%. It means if a satellite is orbiting near the Earth's surface and you are increasing its speed, its orbital speed by 41.4%, then it will escape the orbit. because now its energy is equal to the energy which is required for escaping from the Earth's gravitational field. So it was one of the important problem from need purpose. Again, now we are moving to second concept. What should be its time period if it is orbiting near the Earth's surface? We know that what is V? V is omega into R. V is omega into R. And what is omega? 2 pi by T. So 2 pi by T is root GRE upon RE, means root G by RE. So T is equals to 2 pi root RE by G. You know RE, you know G. So if you calculate this, you will get 84.6 minutes. It means the satellites which are orbiting near the Earth's surface, they are taking 84.6 minutes, nearly 1.5 hours to complete one round around the Earth. In 1.5 hours, it is completing one round. So interesting fact is there. We can calculate the energy, total energy, potential energy and kinetic energy. In competitive exams, they are also discussing or asking problem regarding that. If it is orbiting near the Earth's surface, what is its kinetic energy? Or in general, we will calculate if it is orbiting in its orbit, what should be its kinetic energy? We know the formula, kinetic energy half mv square. It is orbital speed. We know the formula for orbital speed. What was it? Root GRE square upon RE plus H. So it will become half m GRE square upon RE plus H. So it is the formula for kinetic energy. What is its potential energy at this point? What is the formula for potential energy? Minus G mm upon RE plus H whole square. What is GME? GME is GRE square. So for this calculation, I am writing it again, GRE, G into mass of Earth, M by 2 into RE plus H. It is kinetic energy, it is potential energy. So what should be total energy? Total energy. We are going to calculate total energy of satellite. Total energy of a satellite, potential minus GMEM upon RE plus H whole square, kinetic energy GMEM total energy, potential energy minus GMEM upon R, not square, minus GMEM upon R. We can calculate, it should be GMEM upon RE plus H. So we can take common GMEM upon RE plus H. What is the remaining? The remaining is minus 1 plus half. What we are getting? Final answer, minus half. So you saw that total energy of satellite in its orbit was negative. That's why it is bounded with the earth. It cannot leave that orbit because its energy is negative. To move, everything needs positive energy. So this energy is known as binding energy of satellite. Satellite is bounded with earth by this energy. If he will get this energy from any external source, it will leave the orbit. So it is known as binding energy. So if in exam they are asking about binding energy of satellite, what we have to write? This energy he needs. So we are putting plus sign GMEM by 2 into RE plus H. It is the binding energy of satellite. If he will get this energy, only then he can leave the earth's surface. Sometimes they are asking about graph. When we are moving from earth's center away from it, graphically represent the value of G. So we should know that also. What I told you the value of G, it was GME upon RE square on the surface of earth. If we write it in terms of what is mass? Mass is volume into density. Volume into density. I am taking mean density of Earth's material is rho. It is nearly 5.5 CGS unit. So it is rho. 4 upon 3 pi r cube into rho divided by RE square. Cancel 2r. So what we are getting? We are getting 4 upon 3 pi G rho into RE. When we are going inside, what we are getting there? Inside, we are not on whole mass. Now, mass is suppose ME dash. If we are at H depth, so it should be RE minus H whole square. So what we are getting inside, it is G 4 upon 3 pi RE minus H whole cube, volume of this sphere inside sphere, into rho divided by RE minus H whole square. Cancel 2 with this. So what we are getting inside? 4 upon 3 pi G RE minus H. What is RE minus H? Distance from center. If I am writing it D, so inside the surface I am getting 4 upon 3 pi RE minus H means D into rho. So it means if your distance, you are inside the earth's surface, from d distance value of g is this. So if d is increasing, it means g is increasing. At center d is 0, so at center value of g, it should be 0. So if we are plotting, what we are seeing, g dash 4 upon 3 pi, g and rho are constant, it's directly proportional to d. So when you are moving inside the earth's surface, the value of g is directly proportional to your distance from the earth's center. And we know that the graph of this type of relation should be a straight line passing through origin. It means graph should be this. If I am taking value of g on y-axis and distance on x-axis. So it is the graph. Are you getting my point? So many problems they can frame on graph, they can frame on Kepler's law, they can frame on universal gravitational law, they can frame for gravitational field, gravitational potential. So all points are important, but keep in your mind, gravitational potential, gravitational field is just like the electric field. If you have remembered the formula for that topic, no need to learn separately. Same thing you will get here in terms of gravity only. So even they can ask you, if Earth, if you want that length of day become 1/4 of the present, how much Earth should shrink so that length of day will become 1/4 of the present day. If suddenly Earth shrinks without any external torque, what will happen? We know that we are considering Earth as a solid sphere. If external torque is 0, angular momentum should conserve. What they are saying, by what percent Earth should shrink so that the length of day will become 1/4 of the present day. So we know that in absence of torque, angular momentum should conserve, means I1 omega 1 should be equal to I2 omega 2. What is I? 2 by 5 mr square, solid sphere formula. What is omega 1? Presently length of day is 24 hours. So it is T. T is 24 hours. Or they can ask, if Earth shrinks suddenly and radius become half, what should be the length of day now? So both we can calculate. I2, Earth shrinks to half of its radius. So moment of inertia means 2 by 5 m r by 2 whole square. Omega 2 means 2 pi by nu t. What we are observing this? Cancel m with m, r square with r square, 2 pi with 2 pi. What we are getting? T dash is equals to T by 4. T was 24 hours. So now T dash is 6 hours. It means if suddenly Earth shrinks and its new radius is half of the present radius, the length of day will become 6 hours, mean 3 hours day, 3 hours night. Okay, so you can calculate this. They can ask, with what speed Earth should rotate so that the object on equator will become weightless. We know that. What was the formula? Effect of rotation on G. We discussed G dash was G minus R omega square cos square lambda. If objects on equator becomes weightless, what is weight? You know that weight is mg. On equator it should be mg dash. G dash is the value of G on equator. So what they are saying, they should become weightless, but mass is there, because matter is there, it is 0, it means we want G dash to be 0. Putting G dash 0, if we are on equator, lambda is again 0. So omega square should be equal to root G by R. What is omega? Omega should be equal to root G by R. Omega is 2 pi by T. So T is equals to root pi R by G. Means 84.6 minutes. If on equator objects are suddenly weightless, what will be the length of day now? It will be 1.5 hour nearly. It will be 84.6 minutes now. So if we are combining the gravitation with rotational motion, you will get some interesting facts, and they can ask. Now we are little bit discussing that geostationary satellites. We are going to discuss little bit geostationary satellites. What are geostationary satellites? We discussed in previous slide that when we are moving, we are launching one satellite on Earth's orbit. What is the time period? Their velocity is root gme upon re plus h. Orbital speed is root gme. Upon re plus h. It is orbital speed for any satellite which is orbiting at a distance h from Earth's surface. But what is v? V is omega into r. R is re plus h. So what is omega? Omega is 2 pi by T. What we are getting T? T is equals to 2 pi. Take T on that side. Re plus h raised to the power 3 by 2 upon root gme. Root gme means GRE square. We know that what is GME. So we got this result. We know that the time period of Earth is about its own axis is 24 hours. So this satellite is orbiting around the Earth. If we adjust the value of h such that t will become 24 hours, so what will happen? It will move with same angular velocity that is of Earth. So if it is at this point, both have same time period, so both will move simultaneously. It means from Earth, it will appear stationary. So if we adjust h such that t become 24 hours, then this satellite will be known as geostationary satellite. For this, when you calculate h, you will get nearly 42,000 kilometer. Means this GE plus h. So you will get h nearly 36,000 kilometers. So this orbit, radius of this orbit is known as parking orbit. This orbit is known as parking orbit. So when you are launching a satellite at a height of nearly 36,000 kilometer, means radius of orbit of satellite is nearly 42,000 kilometer, then time period will be 24 hours. From Earth's surface, it will look like stationary object. This orbit is known as parking orbit, and this type of satellites are known as geostationary satellites. It was all about the theory of gravitation. Now we will discuss problems based on this gravitation which they asked in previous year exams and some important problems on that.